So today we're going to talk about the front end, and I'm going to try to present you an example application that's very bare bones with Vue.js. I'm going to talk about some concepts in Vue.js on what you can use to build your applications, and again we'll try to have a discussion or a session where we build on top of our existing application and build some examples, some API calls with the front end, decorating it on the front end, and I hope further discussions about user interfaces and architectures. So this is the first time we're touching the front end in this lecture, which is kind of weird because when you talk about JavaScript, people expect that you do front end work, but we only did back end so far. This is the first time that we're gonna deal with the concepts of the front end. So I'd like to start with a couple of questions to understand a little bit more about your background and your history with the front end or your expectations. So raise your hands if you are a front end developer now. What? No?
No, yes, no.
Okay, that's great. That's why I hope you're here. So if you're already a front-end developer and if you are familiar with, I don't know, React, Angular, this will be kind of a recap of what we do or how we do similar stuff with Vue.js. But I hope you'll be starting from scratch. Who built a web page before, like with HTML, CSS, or something? Great. So most of you already know what it feels like to build a front end, right? And who built an application on the front end before? You don't have to be a front end developer, obviously, to do that. You can try out tutorials and stuff. Anybody? Any application on the front end? Okay, great. So the idea is maybe then a little bit of a background context. The web started out as text documents being sent around, and then people said, you know what, text is getting us only so far, so we can maybe do more with images, and if we combine these text documents into groups and links and web pages, it will be better. So they came up with the concept of the markup language, hypertext markup language. So it's what HTML is, which means, as you hopefully already know, which is a language designed to tell browsers to how to display a certain web page. Like this is an example HTML that you see on GitHub, with some elements that are showing, hey, like this element should look like this. It should be this height or this width, and like the width should be 980 pixels wide, and the margins should be set auto, etc. This is done with CSS, which means cascading style sheets. So they define how the web pages would look like. So the idea is we were stuck with this static HTML pages that we could design however we like, but they didn't really do much. In fact, they didn't do anything. They were just good at giving us information, displaying us information. And that's what landing pages are for. We found a way to make money from static pages called landing pages. We do them for once, and then 10 different variations of those, and then display them or send them in an email to our customers so that they click on it, come to our web page, and hopefully buy some of the products that we sell, and we make money. So human mind is really creative. Like when it comes to making money, we can make money from the smallest stuff. And we did that with web pages, but it was not enough because people started spending more and more time on the web. They started creating content, which led to another change in this approach. Now we needed a way to dynamically display content on our web pages so that whenever you write a blog post, you can share it with your followers or with your audience. And this, we built with a server architecture in mind. So we had a backend application, much like we did, creating records in a database and then displaying them, again, much like we did before. And that also kept us going for a certain while. But then, again, it was not enough. It was not enough that, that we could fully express ourselves in the web pages. And then we came up with the idea of applications, user interface applications, which are separate from web pages. Can anybody tell me what's the biggest difference of an application and a web page? They both work in the browser, but there is a significant difference between an application and a web page. I didn't pick anybody yet. Please raise your hand. There are no right or wrong answers. You can just shoot anything. Yeah.
I would say a web page, like you said, it displays the information, you can read it, but an application, it interacts with the user, you can give something to the application and does something with it, it gives you something back. Yeah, for example, you can log in and create something.
Yeah. Any other ideas? The difference between application and a web page. We said that they display information, or you can interact with it, or you can enter information.
Maybe like application is more or less on the device, and web page is on the server.
An application is on the device, and a web page is on the server. That's a very good clarification on the topic. Yeah, an application mostly runs on the client side in the browser and does API calls to the backend to send or receive information. But most of the time, they don't dramatically change. Like whenever you post something to Facebook, you just see it appear in your feed, right? Your chat screen stays the same. The rest of the feed stays the same, so you're not taken to a different context, a different web page. It doesn't refresh, so it just takes the post that you just created, appends it to the list of the feed, the articles that you have, and that's all it does. So this actually leads to something called keeping a state. So there is a certain state the Facebook page was in before you entered your post. And then you wrote something and you clicked send, and then that post appeared on the top of your feed, right? And you basically changed the state of Facebook. Previously, it was displaying something else. Now it also contains your post. So there's a different state. So you actually changed the state of the existing thing that you see, which we call an application. But you're still within the same web page. You're still in the same URL and the same domain, and you're looking pretty much at the same thing. You're looking at your feed, your list of feed items, but you just happen to add a new one to that list of feed. So applications actually come with this kind of interactivity, and you can do stuff with them. Like an image editor is an application. An email client is an application, right? You think about these in terms of real programs, real software that you use daily on your computer. When we do them in the browser, they become web applications. They run on the web. They are powered by web servers that give you the initial starting point, but then there are applications like Google Docs, for example. You open a Google Sheets or Google Docs and you start typing. You're pretty much using an application. You're inside that thing called Google Docs, and you're creating a new documentation. You do whatever you want. You can, draw pictures, draw charts, tables, whatever. But in the end, you're still using the same screen, doing stuff on it. And there, as you do stuff, the state of the application that you see changes. And that is the most important topic and the keyword that you need to remember about this front-end thing. And especially about front-end applications, because we're right now not really interested in static web pages anymore or dynamic web pages anymore that just display you the information, the thing that you're looking for, and then does nothing else. We're talking about stuff that you can interact with, that you can click around and kind of make work. And the idea then is, again, there is a certain state, an initial state, a default state maybe, when you launch an application. And then you change that state by interacting with the application. Okay, this keyword will come up a lot. And if you learn what state is, then basically you will solve the challenges of user interface applications. Because it's all about state management. It's all about how you manipulate the state. You can manipulate the state by changing the URL. You can go to another URL. Like, for example, let's say, you know, this GitHub is also, hello, GitHub is also kind of an application. It's a hybrid between an application and a web page. You can interact with certain functions of it. There are buttons and stuff, but it's not totally like a desktop application. But you know, you see a certain folder structure on GitHub, right? Whenever you press T, it sends you to the search page, and you can search for file names. It says you activated the file finder. Start typing to filter the file list. So, and I'm going to type JSON, and I'm going to see all the JSONs in this repository. So this is already an interaction with me. I'm changing the state. Previously, it was showing the folder tree, the contents of a folder. I interacted with it. I pressed the button T, the key T, to open the search panel, and then, or the file finder, and then I typed something, and based on what I typed, it updated the search results. So I can type frontend, and it will give me this thing. Or it's actually very intelligent, so I don't even have to type the whole names. So I type front/IGN, and it knows enough to filter these, like all the results. This is called fuzzy search because it doesn't look for an exact match, but you know, it has a heuristic or a fuzzy algorithm to give you the matching file names of what you write. So this is already an application behavior. Again, what was the initial state here? Raise your hand and tell me.
Before you start the search, or
Yeah.
before you start the search, it was just blank, and before that, it was just displaying your whole project.
So before I started the search or initiated or activated the file finder, it showed me the whole project, the files. What did I do to get this?
You press T.
Yeah, I pressed T, which is an action, right? I made an action on the application, which then caused a state change. So it was previously displaying the list of files, let's say like this. I press T, and now I'm redirected to the search page or the search interface, let's say. So, of course, state can change on its own. Like, for example, Facebook feed updates itself every 10 seconds or something. That's also valid. But most of the time, there is a certain action that changes the state.
Even the update, is that action?
Exactly.
It is triggered on the video?
Yeah, it's automatically triggered every 10 seconds, for example. Even that is an action. So the second thing that you need to keep in mind is, like, the first thing is the state, right? Everything happens through the state and manipulating or managing the state. The second thing is everything or every management of this state or every change to the state should go through an action. I'm pressing T, that's an action. There's an automated script that runs every 10 seconds to update the feed, that's an action. Make sense? So I pressed T, the action took me to this page, the search page, right? Which is right now a different state. So I caused the state to change, and this is called, the concept is called mutating the state, not changing, because we are fancy people and we like fancy names. So there was a state.
Can you see it?
Yeah.
What was that?
Mutate. There was a state. Yeah. There was a state. I did an action, and as a result, I mutated the state to a different thing. I do the same again. Like a key press is an action, right? Again, I just type F. That was an action, and I mutated the state to display the list of files that start with F. Make sense? So basically, these three concepts are everything you need to know about user applications or user interface applications or web applications. Every problem, every tutorial you see online is trying to solve this problem. There's a state, there are some actions that I can do with the state, and there's a certain mutation that will happen to the state as a result of my actions. Any questions so far? No questions? Come on, there has to be at least something on your mind, right? I'm not going on until you give me one question.
So that means if the arrangement action and mutate into action, so like they are.
Yeah.
They are a cycle or.
Exactly. There's a certain state, let's say a default state, you do an action that causes a mutation, you have a new state. Now, if you do another action, there will be another mutation and a newer state. So that's always in a loop. Come on. Yeah?
So is there a state that the browser is maintaining by itself?
Yeah.
As opposed to what you've done with this website?
Of course. For example, the browsers remember your scroll positions. When you go back to a previous page, it scrolls down to like initial where you were, right? So for example, before we were showing the list of the folder, the files in the folder, and if I go back, I will see that. That's it. If I go forward, that's the state. So browsers are also applications, they also keep state. Any other questions?
Normally, if you have a static page, we do the request and
yeah.
get a return page.
And get a response.
So that's not happening here.
No.
How does that work?
But that's actually a very, very good way to put this. Let's talk a little bit more about that. What happens with web pages, or how you can interact with web pages. What is the thing you can do to interact with a web page? Yeah, but before that, more questions. Come on, be creative. Is everything crystal clear? I don't know if I should take it as a, I don't know, as an insult or that it was very clear. Please.
Is there any kind of listeners which is missing for the sections from making changes?
Yeah. Yeah. So of course there are a lot of different ways of achieving this interactivity. Like, how do you tell the browser to look for that event that you're triggering or that action that you're triggering? Like, why I press some keys, right? I type I, that's a key press, that's an action actually, or an event, let's say for the browser. And there are ways in JavaScript to basically look for those events. You can listen to click events or key press events and others, like form submit events, and act on those. Or you can do a framework that handles most of these things for you, and will basically be doing that. So we won't be manually attaching event handlers and stuff, because that's not kind of needed in 2018. But of course, it's actually a very complex system in its own.
But is the event listening, and as the event started, and do they change the web page, or is it just a temporary file shown on the application?
It's
on the device side.
yeah, it's on the device side. It's a temporary state. It's a temporary HTML structure that changes whenever you type something. So it just, as we developed the API to display the people JSON, right? We said, you know, localhost / person / all, that gave us all the people in our database. This does a call to the backend like that, gets the list of the files and displays them. I can actually hopefully also show it to you. So let me go and type something. Okay, sorry, I forgot. GitHub is actually pretty intelligent. They download the list of the files whenever you open a repository, and this thing happens only on the front end. So they have basically a JavaScript code piece that iterates over through all the file names and searches for the pattern that I typed. So it doesn't even make a request to the backend, to the web server. So it downloaded the list of files, I don't know, 10,000 of them, just the names, and then it can search within those files, file names basically. So we were talking about interacting with the web pages. There is only one way to interact with a web page, and that's by changing the URL. Even if you click a link, that's a change in the URL on a web page. And you change the URL, you get a new HTML, right? That's the way it goes. So, please.
But then, when you type the search, does the URL also change? No, right? It does.
No, because searching is in web pages that doesn't change the state. When you search something, nothing happens. Like you don't see a list of live results or stuff. But what happens is you update the information on the web page, and whenever you click submit, that actually causes or triggers a call to the backend, submits your data, your search query, and then you get a response back with a new URL, like the results page, and then the details of your search query. So again, the interaction only happens by changing the URL or, you know, making a request to the URL like we did with Axios before. So the idea is you don't have any interaction like that. And since the application lives on the server side, all the logic is on the server side, there's only one way to get more information, and that's through manipulating the URL. And that's what we also did with our initial backend implementation. Okay, so let's move forward. Now I built an example application for you. It's in the WTMB.js repo that I guess already shared over Slack. Please clone that if you haven't already. And if you cloned it a few days ago or a few weeks ago for the first lectures, do a git pull. It will give you the latest commits. You can use git log to display the latest commits. It should be implement simple app structure. And whenever you're ready with the pull, you do DockerCompose up. Just to make sure, let's add -- build to the command so that it builds our application from scratch, because maybe we built it before, you know, a few weeks ago, and it has the old commits inside, but I added something new, so the Docker images should be built from scratch. So most of you are new here, so maybe don't really have an idea about what Docker is, why we use it, how it works. Raise your hands if that's the case. 1, 2, 3, 4, 5, 6. Okay, 7, 8. That's great. So those people, raise your hands if you don't know what virtual machines are, or if you've never heard about them. Okay, cool, perfect. Then let's start with the machine. So our laptops is a machine, right? And our servers are machines that are running in the cloud. Now, most of the time, these are all great, and they meet our expectations, but then sometimes we want to simulate certain machines, like our production machines. That's when we make use of virtual machines that are like real machines, but they live in our own computers, for example. Like I have my own computer, my own machine, and I can have, as many virtual machines as I want, and I can install Linux on them, Windows or Mac OS, just to try out different stuff, for example. So this is a good way of testing your production environment, because basically what it gives you is a copy of your production servers, for example. If you're running Linux in production, in serving your web page, you can have a copy of it as a virtual machine in your own computer. Now, that's a little bit taxing, and they require a lot of resources to maintain. That's why people came up with the idea of even smaller units called containers. So they're not virtual machines. They are just logical groups of applications that are running. So, and they think they are running in a machine on their own. So for example, in this example, we have, I guess, 4 or 5 different containers. One that runs the database, the other that runs the API server, the backend server, the other that runs the front end, and the other is the load balancer. I guess we have 4. And the load balancer is a web server that redirects your requests based on the URL. So what I ran with this command, DockerCompose up build, is that it created 4 machine-like environments. And as far as the applications that run in those are concerned, they are running in completely isolated virtual machines, or like even real machines. Like most of them think that, or all of them think that they're running on Linux, but actually I'm running on a Mac. And most of them think that they're running on Ubuntu, on a certain version of Ubuntu. The load balancer thinks that it's alone in its machine, and it doesn't share its machine with something else, but actually we have MongoDB as well running in another container. And MongoDB also thinks that it's alone on its own virtual machine, or again, real machine. So this is a way people invented to streamline development, to ease and speed up development, so that we can have realistic images of our production environment, how our MongoDB would run. It would run on a certain Linux distro, with certain packages. We can replicate the same thing in our local computers, so that we kind of eliminate the risk of a mismatch between the developer's computer and the live production environment. So yeah, I don't see it here. Oh yeah, here. So for example, Node.js version on your local computer, it could be different. Let me try Node-V. I'm currently running locally 8.8.1 in my local computer, but the image that I'm using, the container image that I'm using, is running Node version 8.11.1 that is customized for a Linux distro called Alpine. So apparently this is the version of Node.js that I'm running in my production environment. So I want to make sure that my application runs in that environment perfectly without any problems, and that it's not affected by the version that I'm running locally. So it kind of gives you this isolation. Your local node version is different than the version that's running in the container. As far as the container is concerned, it's running this 8.11.1 version of Node.js, which is very different than mine, actually, than what I'm running on my computer. So that I'm also using this image while I'm developing code, so that I know that whenever I write something new, if it works on my machine, it's guaranteed to work in the production environment, because that's using the same setup.
You saw that Docker and Node, they are the two different now we have two different versions. So do they communicate with each other, or they do not at all communicate with each other, and
They don't.
have any problem with the versions?
They don't communicate at all. So this is running on its own, the API, and I'm gonna actually talk about how we make use of that API in our front-end application, which is actually a different application. But the thing is, as far as, again, the front-end is concerned, it's living on a server, the API is living on another server, and the front-end communicates to the API over a URL. Now, as far as the API is concerned, it's on its own living on a server, but the database is actually on a very different server that's on another server. And the API communicates to the database over the internet. Of course, over local network. It doesn't hit the real internet. But it still thinks it's another server, it's another machine that it has to communicate over the network. Question?
That means, do I think right? That Visual Code is so Visual Code is the interpreter for all the virtual machines, right?
Interpreter?
Or like
No, we just write the code in Visual Studio Code.
Yeah.
And then our application basically, okay, these are old repositories. And then our application or changes are picked up by these servers, and they basically refresh themselves.
And then they deliver it to the Chrome?
Yeah.
Okay.
I'm going to demo that in a second. So let's first start with opening it in the our IDE. Any other questions about a very brief intro to Docker, please?
Can you maybe repeat that part that I couldn't really understand very well? You said like actually we have an API server and also frontend server and also a database server. So like they're all working in a different server and they're communicating via this local network.
Yeah.
So what about this Docker? You said that I'm a developer and I have an older version, and then thanks to this Docker, so I can already check how would it work, how my application would work in the production environment. I mean, maybe customers, server and stuff.
Yeah.
So, but this Docker actually works just for the front-end server or for all of the servers like this?
No, it's actually, it gives you a, let's say, a virtual Linux environment that doesn't have a UI. So it would only work for backend applications or serving HTML files like what we do. You know, that's how we serve front-end applications, right? Docker will not run desktop applications in itself.
Okay, so it's like a replacement for an API and for the database?
Yeah, instead of locally running the MongoDB, instead of locally running the API server and Nodejs, and using macOS Node.js and macOS MongoDB, there are special builds. You can run whatever you run on production, which is probably a Linux server. So this is a virtual Linux environment that runs the specific version that I want in production. So I'm unaffected by local changes. Because developers mess up with their computers, they install packages that are not existing on the production server, and they think that it's working on their local machines, it's perfect, right? Then they deploy code and it fails on the live environment because it's different. Like maybe they change the version of Node.js from 8 to 9 locally and then develop some code and think that it's working, and then they deploy it and the production environment uses 8, and then it doesn't work because there are like certain features are not supported.
So like is there any other server like Docker which would actually like take the front end then? I mean, as a developer, can I see? I mean, I'm simulating kind of the backend and then the API server with Docker, and what about the front end? There's nothing to take it, just simulate it?
Not really. You should use virtual machines, real virtual machines or real machines for that purpose to simulate, for example, Chrome on Windows or Firefox on Linux. Docker doesn't give you much.
Just for the backend.
Yeah. I mean, technically, just for the record, since I'm recording this, it actually does, but it's very convoluted to set it up. Any questions? And nobody uses that, by the way, because it just works horribly. Any other questions so far? Cool. Then let's talk about how this comes into place on what we're gonna do, what we're gonna build, right? Or how do we achieve this? So the front end says your application is running here, HTTP 0008080. Okay, I copy that. Don't follow me. I copy that and type it in the browser. I get nothing. Safari cannot connect to the server because, again, the front end thinks it's running on its own. As far as the front end is concerned, that URL is true on its own server, but you know it's not alone. And I didn't allocate that port to it, and I didn't allocate that address to it. So it actually doesn't really work like that. So in this certain setup, I have this app-local arm.ag as the URL, and I copy that, type it in the browser, and see the output. Hello, you're an unknown user. So this is the front-end application. And who remembers this URL from the previous lecture? app-local.something, 1. Okay. 2, maybe 3. Yeah, all right, that's great. Let's refresh the memories. If you remember on lecture 8, we did deployment and we allocated certain domain names to our applications. And this is one of those, like I used app-local.rm.ag as my domain name. You can pick whatever you want because these are all local, so nobody will be able to use that domain name. But currently what you need to do is you need to edit the hosts file. Again, nano/etc/hosts, and add this line. So, yeah. Oh, yeah. You're right. See, permission denied. So you should run it with sudo nano. Oh yeah, on Windows, I don't know where it is. So 127.0.0.1, some spaces, doesn't matter how many of them, at least one, or a tab, app-local.rm.ag. Please follow that so that you can actually access your web server. Who did it so far? 1, 2, 3. You didn't. You don't have a computer, yeah.
Yeah, I do have, but I already used the half of the lecture, so I'm gonna turn it on.
Okay. Yeah, I'm recording this. Hopefully, this won't have any problems. That's why I have a new computer, so that we won't have any problems this time with the video. And I'm looking forward to your contributions with recording the screen capture for the previous lecture. It would be really good if anybody could take that on. Who is following me? Please, have a question?
So why can't you just access it at localhost or 127.0?
You can't do that because the load balancer is configured to listen to this host. I mean, you can technically do it, but we didn't choose to do it like that because we kind of also want to simulate a real development environment. In real life, this application's URL would be app.arm.ag. And when we're running locally, to separate that, we normally use -local in the first subdomain part. So it's app-local rmag. So it's like a real application. Like if you were, I don't know, docs.google.com, if you were developing that, this would be docs-local.google.com. So I kind of want to give that idea, and therefore it should be as realistic as possible. You can pick anything later. Pick this one right now, app-local rmag. Before we move forward, I have to know how many of you will follow me with today's lecture by writing code, because I'm going to adjust my speed according to that. I encourage you to write code and follow. Question? Okay. All right. So, who saw this? Raise your hands if you saw this. That's great. What about you? Okay, perfect. We have, by the way, again, we have a lot of TAs here. Just raise your hand and they will come to your help. They're actually waiting. So they will be more than happy to help you out. With installation as well. Are you running Windows? Ah, that's great, then it's a lot easier. Yeah, okay. All right. Shall we give a break like for 10 minutes and then start? Yeah, perfect.
Before everybody goes, we'd like to collect some feedback from you guys about the course. So we're going to put some post-it notes on the wall, and then you just write a little note about feedback. Things you can change, things that you like, things you think about in the semester, it really helps a lot.
It's not that I'm doing more to follow you on the like coding and everything. It's like, if I watch you, you're doing the thing.
Yeah.
So I'm more concentrated. So like I can follow you.
Mm-hmm.
And if I'm just doing myself the coding, then I'm lost.
But that's why I asked, because I want to go slower this time, and give you enough time that you can catch up.
Yeah, so that's why I wanted to know that I'm in, but like this is my way of. So the moment I just get into the computer, then I can't follow you. So I want to follow you, but I'll see the video and do that.
Yeah.
Did you know that it's not that it's nothing else? It is just my way.
Thank you. No worries.
So this is all how you have it set up in Docker. So I guess by default, in this project, it says it's only going to listen to when it's referred to by that name. So by that name, tells it to, right? If the user has access to this name, it like actually proxies them. So it's actual, okay, it's actually on 0.0.0.0. The name is still the thing that's Okay, so you're in the main project directory, you're going to document. It will list the project. So you probably actually okay, either way. So you went to the directories and you ran like an start. Yeah, so that's hosting it. Different. So the Docker command goes through Docker. So Docker is you also run it slowly on your
I think those ones like
Do you follow the service? Do you actually treat yeah, so yeah, basically Docker takes all the files and it puts them into the Docker like yeah. And then Docker does Docker that's how this specific I guess yeah, I'm not the expert, but we have like machines let's say it's going to use this file and see stuff a little bit something
Great.
This somehow
So you should, I guess it's a separate installation on
just to be something. And it's basically authentication and should be able to be taught by using I have to use this so that's the reason why you have to tell the computer when you call this URL redirect it to
Can we start?
Okay, right. I use that. That's interesting. Okay.
I'm gonna start. Not ready yet. Okay. We have again a lot of TAs here that will help you get on board. Marit is here. Anya is there. Ömer is there. Raise your hand, and they will help you install stuff and get started. Try to catch up as much as possible. I'm gonna go a little bit slower when I'm writing code so that you can actually follow, write, and listen. So we'll try that. But okay. So who could actually see app local RMag on their computer? Running this, okay. Not very promising. Raise your hands if you need a couple of more minutes to finish your work and follow up. Otherwise, I'm just gonna go with this for 5 people. Okay. Then I'm going to talk a little bit about the concepts here. Okay. Sorry. Now, the first thing that Matt, you're too loud. Maybe change places. The first thing you'll notice in this application is that it's an application that we wrote before for the first week or the second week when we were talking about authentication. So this is the exact application that I showed here, and I also asked you to implement Twitter authentication, which was already in one of the branches. So none of you did it. That's perfect because we already have it here at our disposal. So the idea is this, again, is the exact same application, and we're building a front end for that. I mean, actually, I built a very dummy, very small front end to just show you the basics of how we develop stuff. Okay, and I just opened one of the source files here. But what you will notice here is we now have 2 main folders. One is the API folder, the other one is the front-end folder. Okay, the API folder has all the previous code that we wrote or that you had before on week 2. So it's the same backend application that created persons, that created accounts, that logged them in, that did Twitter authentication. All right. We took all those source files, put them under a folder called API. Why do you think we did that? Yeah.
So it's easy to find them, so if you need to check everything, it's just one place and you don't have everything everywhere.
Yeah.
Just go for them.
Yeah, because we will build a full stack application that will also have a front end. So we want the front end files to live under the folder front end. Again, it will be it will act like a separate web server, right? So we keep that confined in its own folder, and the API as well is confined on its own folder. It has, again, all the previous files, including package.json and our Docker file and our source code. So these are everything in the API folder. We also did something different. Beforehand, when you just went to the home page, like localhost 3000 or something, you saw this web page. But now the URL is changed. Now the home page should serve our beautiful web page, right? Our beautiful web application. And the API should live somewhere else, not on the home page. That's why we said, okay, URLs that start with /API, they go to our API server. Okay? So previously, to create a person, we would use this Axios post /person. right? This is what we've been doing like since Middle Ages to create people. Now the URL changed because everything that lives in the API application is in the API server and not on the home page anymore. So we have this /API in the URL. So all of our existing URLs changed to include /API. So API, of course, it requires login. Login also changed. It was beforehand localhost /auth/login. Now there's an API in there. Because again, this is the same backend application. I didn't change anything. So app local rmag /API/auth/login is the URL. And then, you know, we have the regular homepage that is now served from a Vue.js application. So that's a front-end application already that lives in the front-end folder. Okay? Now, please.
That means the two front-end pages that we saw, one is in front-end, one is in API.
Yeah. The front-end folder is a Vue.js application. Starting point for you. Like if you want to develop full-stack applications, like, you know, maybe that's the case and you have to apply for a job and then they give you a technical challenge to build full-stack applications. That happens sometimes. You can use this boilerplate. Just clone this repository, it gives you everything. There's the backend code, the front-end code. You don't need to set up anything on your own. But what we did is there is a Vue.js Webpack template. It's this GitHub repo. Vue.js templates Webpack or Vue Webpack boilerplate. This is the most common boilerplate that's used with Vue.js projects. And we set up a copy for you in this repo and made sure that it works with Docker and it works with this URL scheme. Actually, Mark did that. So, like in the last 15 minutes. So that you can run with this, okay? It gives you a bare-bone Vue.js application that includes everything, even end-to-end tests that run in the browser. So I'm not going to go into the details of testing today, but basically it's everything set up for you to deploy your application, to write your application, run your application, to test it, both the backend and the front end, everything is in the repo. And I'm going to talk about how we did that, the file structure here, and I'm going to talk a little bit about Vue.js concepts on this. But first, I want to show you the application, so we need to log in, because when I want to do API person all JSON, it redirects me to the login page. Follow me to the login page, and we will create a user account and log with that user. Does anybody remember how we created user accounts here from the second lecture? Kinda, yeah. Something like that. Anybody? Okay. Well, it's as simple as this, or let's say the first part, axios.post/API this time, because the URL changed again, /auth/register. Okay, please type this. Yeah. Sorry? Here, the URL is, it's app-local.rmag/API/auth/login. Did you create or register the users? What we do here is we create a user with a username test and a password test so that we can log in, because there are no user accounts, right? The database is empty. I, of course, have one user account set up. So you do this and then you type test. and it will log you in, hopefully, when you click login. Did anybody log in yet? One? Great. Axios.post/API/auth/register. And then we pass in a JavaScript object that represents a user. It's like an account creation form that we're submitting this information. The rest, the console logs that are kind of unnecessary for our purpose, but it's a good practice to have them so that you always get logs of what's going on. I get an OK back. And I'm going to click login. It gives me my username. So, hello, your test. And again, if you look at the URL, this is /API, which was previously just the homepage, just the regular homepage /, right? So this is served by the backend. This is served by our backend application. Okay. All right. So raise your hands if you saw this hello page. 1, 2, 3. Yeah. Yeah, make sure that you're at /API and not the home page. I didn't set that part yet. So the Vue.js application, the front end, doesn't know about the user yet. I mean, that's what I created, yeah. But you can use any other password. You cannot log in unless you create a new user or you register a new user. And the way you do that is by typing this in the console. There. Okay, come on, I need more hands to do this. Raise your hands if you saw this so far. 1, 2, 3, 4, 5. Okay, 6. Good. Anybody else trying to catch up, or should I move forward? Okay, completely broke. All right. So now let's go to API/person all JSON. The URL is displayed here. App local rmag /API/person/all/JSON, and it's an empty array because we don't have any records in our database. Okay. We just created a user, but we didn't create a person. Person is the name of our records. The way we we do that is by doing axios.post. And yeah, I think this would do. Axios.post, it will be /API/person, that's right. We're passing in a name. Let's also pass in an age. I don't know. And then we log the data. Oh, we don't have Axios here. So I do it on this page. /API page, because I have Axios here. I run this, and I create a new person. This is the stuff that we did last year, and on the second lecture as well. Axios.post API/person. And when I go to the person list again, I see that the record is created here. So on our backend, on my database, I have a record, a person record, who have no friends right now. All right? Now, this has nothing to do with the front end yet. This is just some data so that I can make a useful front end application. And that's good if you share it, the URL and stuff and the commands on the Slack channel. That would definitely help. Okay, now I'm moving on with the actual front-end bits. All right. First, I want to display the list. This is again coming from the backend, from the API. /API/person/all just gave me this dump. So we have a table ID, name, and age, and then we also have this this JSON document that's printed. All right, this is still stuff served from the backend. Normally you would delete all these. I'm just keeping these for reference. Normally the backend wouldn't serve this HTML. The backend would only serve the JSON, which is again by adding JSON to the URL, to the end of the URL, like this. The backend would do this, but for historical purposes, we also keep that. Now there is a front-end equivalent for this in our API, in our front-end application, and that is the URL /hash/person. So here, that is the URL /hash/person, and it gives me a different formatting, a different list that is now the actual Vue.js application. And I'm going to talk about how we did this. Okay. Did you see any weird stuff in the URL? Does it look different?
Hash.
Yeah, there's a hash, right? Why do you think it's there? A counter? Makes sense. What else? ID, yeah. Anything else? Why do we have a hash in the URL? Please.
On the front end now.
Yeah. We're on the front end.
It indicates the path.
It indicates a path. Yeah. Any other answers? So now there's a concept called applications, right? Web applications. There's a little bit more advanced version of that called single page applications, that you only load the HTML once, the page doesn't change, and the application runs inside that page. So that's why it's called single page applications. So the idea is you never get a second page from the web server, from the backend. You only get one HTML and the application runs there. How we do that again? We do that by manipulating the URLs, right? That's how we get a new web page from the backend. And here, the idea is if you put a hash, you don't navigate away from the current page. If you put a hash to the URL, you stay in that exact page. For example, this is a web page, and this is a link to the usage page, usage section. All right, and maybe another one for what's included. You see the hash changes here depending on the title that you click. The title, Vue, Webpack boilerplate, documentation, usage. The hash changes, and it's an anchor. It's called an anchor. It shows you where you would land on the page. Like if you refresh this, you always end on the usage. Or if you share this URL with a friend and they open it in a new tab, they get the usage section. So this is already kind of like routing or URLs, but for single web pages. That doesn't change the backend, and it doesn't make a new request to the backend. Now, people abuse this functionality, and because you can hijack this. You can listen for the URL change event, and if it contains a hash, You can prevent any default action like scrolling. You know, when you click this, it scrolls to what's included. You can prevent this and then do whatever you like. For example, display another section of your application, right? And you know, once you hijack it, it just doesn't matter what you want to do with this. You can do anything. So here we have two different views, let's say. The first one is the actual hello page. You're an unknown user. That is, you know, just hash. And then when you add person to the end, you get to the person page. So this is a different page already. This is a different route. It's like a different URL, but it doesn't go to the server. We intercept it and display this new user list. Does it kind of make sense? This is an intelligent hack of the use of the hashes. Instead of scrolling the page, we intercept it, go in the middle, hijack it, and do whatever we want, like display another page or another view there. Okay. Now, of course, yeah, please.
Animal, then you're actually like directly jumping to this paragraph under the title of animal. Is it true?
Normally that's true, yeah. But here we don't do that. Like there's no scrolling. What we do is we listen to the navigation event, and whenever this happens, we prevent it from actually doing any scroll or looking for the animal on this page, and we hijack it and display our purpose, our original purpose, you know, the page that we set up for animals or person, in this case.
So actually that was what I meant. I mean, not like scrolling down, just like directly focusing on the title that I'm looking for.
Kind of, like because there's no other way, for example, to get back to that page earlier, unless you go back. So here on this page, there's no way to get to the person's page, not like a regular web page where you can scroll. You cannot click anywhere and get to the other place. You can only type person at the end of the URL and you'll get this. So it's kind of this hidden, but not even hidden. It's not there. Like this person list is not there unless you come to this URL. And when we browse this URL, the browser knows, okay, this person is trying to display the person page, so let's display that. When you don't have the person at the end of the URL, it says, okay, this person is trying to browse the home page, let's show the home page. This is how we do front-end routing. This is something that you can read more about. It's called front-end routing. And one thing we did is, this thing is very common. So everybody started using hashes or something called a hash bang, a hash and an exclamation point. And this was the usual way to do front-end applications or single-page applications until 2011, 2012, where browsers implemented a new API called the History API, HTML5 History API. And now, what we can do is, we don't need this. It requires a certain setup in the backend and in your Vue.js config. We don't have it right now. But normally what we do is, we omit that hash. We don't need it anymore. And we just go to the person. Of course, mine doesn't work, but it's the idea. We can get rid of the hash and it will still work. It will still route without hitting the backend. So we don't have to use the hash anymore. But you know, for historical purposes and for supporting more browsers, more older browsers, it's still used like hash when developing or when starting out. If you need a more professional or modern look, you can remove this in the configuration. All right. So I have this list. This is the front-end list, please. To login, I think it's API auth login. No worries. Okay, so I have this person list, okay, which is really instant. And when you look at the network requests, there, when we refresh the page, when we refresh the page, we see that there is a request made to the JSON URL, and the request URL is applocal rmag API person all JSON. So it's requesting the JSON from the backend and displaying it in Vue.js, right? If you don't have this this JSON here, this won't work. If you remember, we also did a middleware, right, on the backend. So this is already live reloading everything that you're writing. So we can send an empty array here and refresh this. You'll see nobody. There's just no one. And if you send the people and refresh the web page, yeah, you're supposed to see everybody. Oh. What's going on? We're logged out, right? Because we restarted the server. I need to log back in. Okay. /person, yeah. You see the list of the people here. All right. Do you recognize a flash here? Like there's a certain thing that's happening. I don't know if I can show it. Guess I can't right now. But the idea is, this is doing an async operation on the web page. The first thing it does is it loads with an empty list. And if the people are empty, we see there are no people here. It then does an asynchronous request to fetch the list of people, and then loads it. So until the response arrives from the server, for a very brief period, you see nothing is there. So how? Sorry? I can throttle the network, yes. Where is it? Settings? Okay. Here, network. Yeah. Okay, yeah. All right, slow 3G. Let's refresh it. It's loading slowly. I'm getting the front-end application right now, downloading the app. Okay, it's a little bit too slow. Come on, it's like 14 seconds. See, there's no one yet, and then the list refreshes. Saw that? Let's do that torture again. It's like going on forever. First it will show you that there are no users, and then it will display the list of users, because that's an asynchronous operation. Hopefully. Yeah, there's no one yet, and then here are the people. So, thank you. Let's see how this works in real life, in code, right? We've been waiting for that for a very, very long time. One thing that you'll notice here is that for the front-end application and for Vue, everything is under the source directory. So anything outside the source is not that interesting anymore. And we have our components and everything that we're interested in the source directory. Now, what did I talk about as 3 important concepts in the first part of the lecture? No, that's cheating. That's not allowed. So I talked about 3 important concepts about front-end applications that you have to, please. State, action, and mutation, right? And the front-end applications, again, are all about creating a state and mutating a state. Now, can we talk about a state here, and an action and a mutation? Let's identify the states, the actions, and the mutations on this network here. Anybody? Some new faces, please. So, what is the state, the action, and a mutation here? Please raise your hand. Please.
I would say the initial state is that you do not have anything.
Yeah.
And then the action is that, I mean, when you log in.
Okay, that's like Big Bang. Let's not go that far back. Let's
okay.
About this web page.
Okay, when you load this page.
Yeah.
Then the action is that the users are fetched.
What is the state?
The state is you don't have any.
Okay.
And then, yeah, the state is there are not any users.
Yeah.
Then the action is fetch the users.
Yeah.
And then the mutation is the new, here are the people and the list of people.
Perfect. Who followed that explanation? That's great. Then, would you like to repeat?
Yes, so we have 2 different states and 1 action. The default state is an empty page.
Yeah.
And the action is fetching the data.
Yes.
And the mutated state is the current state, which is with data.
Perfect. Is it clear? The initial state is we have 0 users, we have an empty array, right? That's why we see that there's nobody yet. Then we do an action that's automatic on the page, like whenever the page is created, we do an action to fetch the list of people, and then we mutate the initial state by replacing that empty list with the list of people that we received from the backend, right? And then we display it on the front end. Does it make sense? Okay. Please.
About the action exactly, because it's a refresh, but actually it's a request to the server, and the response is the data.
Yeah.
So
the refresh isn't included. Let's say it's there by default. Like it's my way to reset the state and to, show this again. So the application starts actually right now, like after all the resources are downloaded and loaded. If you see here, when I do a refresh, you see that it first downloads app.js, and it's quite a sizable thing, and then it downloads, like it gets the JSON request and some other stuff. So the application starts when all these things are downloaded, like when app.js is downloaded, parsed, and applied. And we count from that onwards. So the initial state, again, there are no users. The action, we load the users. The mutation, we replace the list of the empty list with the new user list. Okay? Question? Yeah.
I have a question about this method. When we, for example, when we're in the initial state and when we have an empty array, are we also seeing, because to be connected until we catch it, like are we also seeing this get method, or we don't see any other method? I guess this get
Yes.
is to fetch the people, right?
Yeah.
So before this state, do we see any method or nothing?
No. Initially, we have nothing, and then we do the get person or people, and then we see this list here. And even if we didn't have any people in the back end, we would still do the get request, and then we would get an empty response.
Okay, so I see the get method every time before I reach the state.
Yeah.
Okay.
Or like, let's say, after the initial state, after the action, because the action is to fetch the users. Okay, now this is the most important thing that you have to learn about user interfaces or web applications. And if you can manage this, you know, what the state should be, how will you interact with it, what are the actions, and what are the resulting mutations, then you're already a very, very good front-end developer right now. The rest is, you know, up to you. You can learn CSS, you can improve your HTML skills. They are relevant today, less relevant than they were like 10 years ago. Today, what you have to learn to stay competent in this front-end game is this state management. The initial state, actions, and mutations. That's mostly it. And then there is the second most important concept, and that's called components. I'm not going to talk much about that today, but I would like you to think about IKEA furniture or Lego building blocks. That, you know, very generic items that you bring together to create something new from scratch, right? And you can reuse them. Like, you can take a block of Lego and then reuse it to build other structures, right? They are called components. You may have heard a term called electronic components. Anybody heard that? Electronic components? In any context? Yeah. The reason they are called components is because they are reusable elements in building electric circuits, like resistors, capacitors, transistors. Like, there are 100 billion transistors in modern CPUs, right? They are 100 billion different components that come together to build up a CPU, an application. That's what we use. The same context is what we use to build applications on the front end. And it's very important for you to learn the idea of components and how to break down components. Okay? Let's talk about the example of Google.com. The homepage of Google. Let's talk about the components here. What components do we see on this very, very simple web page? Fields, buttons, they are components, yes. Like search Google, I feel lucky. The search box, they can all be different components. Sorry? Yeah. This one? The square one. This, yeah, for other Google products, right? Now, the idea of components is reusability. So if you're going to reuse a component, then that is a component. If you're not going to reuse a component, then it's not a component. Okay? What is the elements of reuse here? And reuse means to make use of the same component in a different page. Like, for example, here. Okay? What elements are reused between these pages? Yeah. Let's put them together. Yeah. What elements are there that are repeated? Please. The drop-down menu, yeah. Yeah. So these are definitely components, right? That you want to reuse. Now, I would say that this can be a component on its own. The login button can be a component on its own, which means, you know, maybe some of the time you don't want to use them together and you want to use them separately on different applications, then that makes sense. Like, for example, when I log in, right? What happens when I log in? So that login button disappeared, but I still see that drop-down menu, which means it's definitely a component on its own. It can be used on its own. Then the search box as well. That's a component, right? What other components do you see here on this page? Yeah. Exactly. So each search result, we have something called a search result component, and we're repeating it. Like we have 10 results here. This is the first one, the second one, the third one, and these are not that special, and we repeat them. There's a pattern, right? There's a repeating pattern. That's the perfect opportunity for making this into a component. So, there are two stuff that you have to master. And once you master these, it doesn't matter which language you're writing user applications in. It doesn't matter which framework you're using. You'll be a great front-end developer or an application developer. Even iOS applications, Android applications. Let's therefore repeat them. Please raise your hands and tell me the two important topics that we have to learn and keep in mind. The one had 3 different names in it, please. Yeah. State management. Yeah. One is state management, actions, mutations, and the state. And the other one is components. Look to the world and you'll see a lot of components. Like the desks here are definitely components. The bottles, they are components, they are reusable, right? And everything that we do is made up of different stuff coming together. And the best architects, the best engineers are the people who knows the best way to break these components. Like, believe me when I say this, I've seen certain components that are implemented that gives you 3 results and they repeat that. Like they don't have a component for a single search result and repeat that. For some reason, they have 3 results in a component and they copy and paste code. It displays 1, definitely. They don't have the others. But if they have 4, they have to copy and paste or create a second component that again can hold up to 3, which is very weird. Like, I don't know. It just happens that people do these decisions. It's very hard to believe. And you'll see a lot of these examples online on GitHub in open source projects. Component design is a very important topic. And you should master that. Like, how do you make the difference between should all and videos be separate components or the same component with a different text? How do you decide? This is very, very deep down architectural discussion. Like this all and this videos, these boxes, should they be the same component with different texts, or should they be different components?
I think they should be one component that is reused, and then you use something to write into it.
Yeah. Any other ideas? That's a valid implementation that would work.
But at the same time, sometimes they completely different kind of visuals, so you can actually have different components. Because of that, because like if you do a map, you will have maps, and you want to have like just different things and different search, and images with different images, so it doesn't make sense for everyone to different components.
Okay. So you attach or you align the components based on their purpose and what they're doing. Yeah. Okay. Any other ideas? I would go and there. Yeah, please come on.
Well, it depends on the functionality. So these buttons at the top, all the videos have the same functionality of the rollover, the blue rollover.
Yeah.
So that's a classic case of being a
Mhm.
that has extended functionality to it.
Yeah.
It's totally based on the same component which has extended functionality.
Great. I could talk until morning and convince you that these shouldn't be components at all. They're just links. When you click on videos, it goes to a different URL. When you click on all, it goes to a different URL. They don't really do anything unless like you have this overlay with settings. So they're just dummy HTML elements with some CSS styles on them. And what I would call a component is the whole container here that actually does something. That's my toolbar. That I can reuse that toolbar with a similar configuration somewhere else. This would work. Now, this is why you have to master this thing. I don't claim that it's the best implementation, that not making them components at all, and just having the toolbar as a general component, and these are just dummy HTML elements. But if all you're going to do is to have some links here, href links, then maybe you don't need a component. Not everything has to be a component. We should definitely make use of HTML. And you see here, these are divs that have A tags in them that just have some hrefs. Is a certain repetition, that's correct, but it doesn't mean that these have to be components. This could very well be, you know, this thing could very well be a component on its own, so that you can make use of it in other contexts as well. It just depends on, see, it's called top navigation. It just depends on how you want to reuse stuff. And the idea is, if you have a lot of components, the number of components that you have is like 100, 200, that goes out of hand very quickly. Like, if you create components for everything, it's really hard to find what you're looking for, to remember all of those. And when you have a new team member, you have to teach them all the components that you are using, because they are custom, you're building them from scratch. So you have to keep a balance between reusability, maintainability, teachability, let's say, and your personal taste, basically. And flexibility, yeah. So definitely making different components for videos, maps, and images, that is a little bit over engineering, because they are just simple links that refresh the page and send you to a different location, to a different address. Okay? Does it kind of make sense? This is a field of study that's been going on for like 50 years. The best way to find how to break down components. It's not a solved problem. It's an NP complete problem for all the engineers out there. There's no true solution for this. It's you know, it's what good design and bad design is all about. And that's what makes you a very good developer, a senior developer, and a junior developer. And you should work on your skills on identifying the components on web pages or on mobile applications or anything that you interact with, and this skill so that you develop that. Like, for example, take the CPU, right? That's a single chip that you can buy. They decided that putting 100 billion different transistors in a single CPU is the most sane way to do that. Because that you can buy, and that does something for you. That does calculations for you. You can put it on a motherboard, it works. If you had to bisect it into 4 different components, if you had various components, like a billion components for what's inside, that would be really hard to use, right? If you wanted to build your own computer and you had to bring together, I don't know, 10,000 different items, that would be really, really hard. So this is a topic of discussion of architecture. And again, this is all I'm gonna tell you about for components. I encourage you to further study them and how to build components in user interfaces. But that brings me to our next topic. In modern frameworks like Vue.js, React, Angular, or others, everything that you see other than the HTML objects are components. So every class that you have is a component, is manifested as a component. So what do we have here? We have an index component, for example, okay? And a person component. A person component displays this list. An index component displays this. This is the index. It tells me that I'm an unknown user, all right? Now, let me keep this here. I open the index file and type Arman. I save it. It automatically refreshes the browser. It doesn't actually refresh the browser. It refreshes the data, the component that I wrote. And I see it here as your Arman. Whatever I type here as the username will display there. See, your test works. If I go to the person component here, I add, I don't know, something. I save it. It automatically refreshes. The idea is even the pages themselves, these are different pages or different views, and it's where the name of the framework comes from, Vue.js. It actually means view because it kind of sounds like view. These are different views, right? Even the views are components in themselves. We implement this people listing as a component. We implement the index page as a component because they decided that a component is the most basic and useful building block in modern web applications, and you have to build everything with a component. If it's a UI thing, you build it. But let's see what we have in this people component here. We have a title and H1. We have a paragraph. We have a table that displays the people's names, right? Now, let me show you where this comes from, actually. If you remember, the one on the right is the one we originally used in our backend that serves our backend, okay? The pug file, the layout or the template for our backend that gives you exactly this API person all, this thing. So the one on the left is its version built in Vue.js, okay? Which is very simple. It's the same language, basically. This is also pug. How do I know that? I have the extension pug here, and I know the language. I see the language pug here. So this template is also built in pug. It's a little bit different. I added a new element to the top called person list. I changed something a little. You know, the if statements change. But this is a very good example. On the left, you have if people.length. You know, if there are any people, display them in a list. On the left, you have something called v-if. And you still do people.length. V stands for view. If stands for a check, a conditional check. This is an attribute, this is an HTML attribute. And it says if there is a property called length in people, or if it's greater than 0, if this is truthy, display this, all right? And we had else here, there's no one yet. We have that else here, v else. This is just a different way of showing conditional data in a Vue.js application, all right? And can you spot any other difference in between the two? Oh, this one. Yeah, let's not look at it right now. Let's first focus on the template. Are there any differences in the template that you see? Come on, please.
Yeah, you also use it before instead of each, and also you reference
Yes, perfect. Thank you. Thanks a lot. That's the spirit that I'm looking for. So we have V4 here, and each here. Again, this is a different representation, language differences. Although they are both POG files, this is specific to Vue.js. Again, V stands for Vue. And this is a loop. You know, for each person in people, display them. This is the same here. On the back end, you say each person in people. So what it does is it repeats this TR, which stands for table row. It's an HTML element. It just creates a new row for each person that we have. Let's create a new person, shall we? Here, I'm going to the console again. And I think this will work. I need to go to API. Let's try. Remember, how old are you? 28. All right.
Disclaimer.
Let's refresh. He's lying. So I have the second person here. Okay. And in the front end, again, if I refresh, I get the second person. What it did is, let's open the HTML representation. So, see, it created a very nicely formatted HTML for me. TR, the first result, TR, the second result. Here are the people and everything. So it actually stripped out all the unnecessary information here, like vif or v4. This is a little bit different than Angular. If we were using Angular, you would see these directives. These are called directives. You would see these directives in the output HTML. Vue strips them out for you and gives you a very nicely formatted HTML list. How does it feel so far? Interesting? Please.
One question regarding virtual machines. So now we have different virtual machines. So Sommer and Matt, they are in the MongoDB.
Yeah. So Ömer and Mert, as people, live in our database in one of the so-called virtual machines, Docker containers that we have.
Yeah.
And then the backend API is in another one that reaches out over the network to the database, fetches the results, and sends it back to the front-end application, or let's say the server that serves the front-end application, which is another container.
My question is, who is the communicator, the browser?
Yeah, the browser talks to the load balancer. If you remember, that's the fourth person in this container thing. The browser, when you write app local rmag, it goes to that 127.0.0.1. That is met by the load balancer. Load balancer looks at the URL and says, oh, okay, the front end one actually serves this. And I can show it to you pretty straightforward here in DockerCompose. Oh. You see we have 4 different services, the API, the front end, MongoDB, and load balancer. And you see here, the front end is listening on a virtual host called app local rmag. If you change this, you also need to change the URL in the browser and the host file. So the load balancer says, okay, I'm gonna knock on the door of the front end. It will give me whatever it gives. And the same we also have for the API. If you look at it, there's also a virtual host declaration there. But this time we have /API here. And what we this means is, if there are any requests to any of the URLs that start with /API, okay, go to the API service, which is another Docker container. Make sense?
Yeah.
That's how we differentiate the URLs, and that is, the communication is again the responsibility of the load balancer. If you're looking for any URL that starts with API, you go to the API container. If it doesn't contain any API, you go to the front-end container, which gives you the Vue.js application.
So that means if we just split the state management, so we have Scratch, then we have action, and then mutation.
Yes.
And so like we have API, and then we have MongoDB.
Yeah, but state management does not go that far back. Again, that's Big Bang. State management happens inside the application. It's not that far back. So it's all happening on our browsers, inside our browsers.
So you steal my question.
Yeah.
So
That's my job.
Yeah, so you
Yeah.
answered that. Okay.
So
That's on the device.
yeah.
That's happening on the device.
Yes. What the virtual hosts do is they just give you the HTML and the JavaScript.
Right.
And the browser makes it into a state managed application thing. Okay, so we have this list. We can show, like in a for loop, different people, right? Then let me reveal to you how other stuff works, like how we actually get the list of users and make it work. Okay. So let's go back to the person component. Each component in Vue.js has three parts. One is the template that shows the HTML that we want to display, that we want to have. That has a script that does the business logic, and that has a style. Well, this one doesn't really have a style, but let's go to index. So you have a template. It says, hello, you are this user. It has a script to do the actual business logic, the actual code, and then it has a style. So in a single file, you have all the responsibilities that you need to show a component anywhere on the page. So again, we have the scripts to write business logic, we have the style to write CSS, and we have the template to write HTML. And they don't kind of mingle. It's very nicely structured and laid out for you. This is the best thing I like about Vue.js. You have single file components that you can do everything with. You don't need separate files for templates. You don't need separate files for the script or the CSS. It's a lot easier. So let's go back to the person. Person list doesn't do anything special, so it doesn't have any style, but we could definitely add some style. If I start by typing style here, it actually auto-completes already with a lot of stuff. For this, you'll need to install an extension for Visual Studio Code called Vetor. I will talk about that at the end. But you can do style with CSS, less, post CSS, Sass, stylus, whatever you want. Okay, you just type it, and it will give you your place to write your styles. I'll talk a little bit more about that later as well. Now, this is all the code that is necessary, and this thing matches the exact same terminology I've used so far. I talked about a state, talked about actions, and I talked about mutations. Now, let me actually show you how the business logic side is handled, okay? Now, this is a file called person.js. This is a store module. That's kind of irrelevant right now what a store module is, but this is where we have all the business logic of our application. And currently we're fetching the list of users, right? So What do you see when you look at this file? Tell me. Raise your hands and tell me. Okay, thank you. Yeah, we cheated a little bit. She's my intern, so. But yeah, it's very simple, right? You have literally 3 variables there. The state, the initial state, that's an empty list. Okay? You have an action that says fetch people. And it does fetch people. And as a result, it commits a mutation. And that mutation is, you know, people request succeeded, request people success mutation. What does that do? What does that mutation do? Here there's a single line. No. Tell me what that mutation does. Someone else, please raise your hands. People who didn't talk today. Well, we can go with you again, please.
I think it assigns the state of received data.
Yes, that's straightforward, right? Like on line 11, you do assign the incoming list to the existing list. So we had an empty array called data. That was an empty array before. When we fetch the people, we get the results, right? And rest.data actually gives you the JSON, that is the list of people, the array. And we commit a mutation. That's how it's called, committing. We commit a mutation and send that data, that list, to the mutation handler, which just assigns it to the incoming state. It's as simple as this. Okay? Now, the beauty of modern frameworks is this thing is repeated everywhere. This structure is called Vuex, which is a wordplay on the word Redux. So this is called, let's say, Vuex, and it's a wordplay on Redux, which is kind of the best state management solution for the React framework. So this thing is inspired by React, and it's infinitely simpler than Redux, and Vue also is infinitely simpler than React. So Angular also does these things similarly, or they started to do these things similarly. You can also use React and you can also use Redux with Angular as well to do state management. But again, this is the problem, the state management thing. And the way we do it is by repeating this thing over and over again. For everything that we want to do, we have an action that, as a result, commits some mutation. That, as a result, changes the state. So you keep the state of the application as an object, okay? And with certain actions, you change that state. Then, what happens is you map this state to your component. So the state is the only source of truth. But it may not be, like the truth may not be as visually pleasing all the time. So you may need to transform it to make it look better, or you may need to reach down into the state to get something that you're looking for, like the list of people, okay? And if you go to our template here, HTML template, or let's say pug template, we used a variable called people. We were checking its length. We were checking, you know, each item in the people array is a person, okay? Where do we define that it's people? In the state, it's a generic name called data. There's no people here. There's no person here. It's just data. The name of the variable that we keep in the state is data. And if you remember, this is the person module, all right? So it makes sense for, as far as this is concerned, this is data of the person module. It's correct, right? But it's not how we want to display stuff or see stuff in our component. We want to call this people because they are people. We don't want to refer to them as always the data of the person module. If we wanted, we could do that, but that's a little bit convoluted. So what, what we do is we map the existing state to a different form that we can work with. We say, hey, I want to work with people, with a variable called people, okay? And the way I do that is by giving it a function, an anonymous function. It receives the state, the whole object, and our task is to find the data that we're interested in. And again, there's the whole state, there's the person module, which is a portion of that global state, and we are reaching into that person module and grabbing the data from there. If I renamed this to, I don't know, a list of funny people, okay? I would have to update this here, state.alist of funny people equals data. That's because that's the mutation. And I would also have to update this here, state person, a list of funny people. This thing would also work, please.
But in the previous one, you also have to update like with the brackets and so on, like state data, you also have to,
No.
and the red data?
No, because this is coming from Axios.
Okay.
This is the response of Axios that doesn't change. And this is how I want to keep my state in this module. This is why naming is very important. Everything should make sense in its own file or in its own context.
And the other data, so with brackets, state data, what does it come from?
Which one?
So request before success, bracket, state, comma data.
This one? They're just parameters that the mutation function is passed. Whenever you commit something, it's it's a result of this action. When you commit something, Vue.js takes this and finds this function and calls it for you, passing in a state as well. It passes the state at that exact time and passes the data or whatever you send as a parameter. Like you could do 3 here, let's say, and you could have another variable here, and it will pass that to you as well. So it will pass 3 for no there. I'm not going into the actual details of how you would write this or you know, how to build this from scratch because we don't really have that much time. But I want to show you the basics, the underlying principles, and then, you know, as a homework, you can, hopefully you will build, like you started doing homeworks, that's great. We had the first homework submission this week. As a homework, you can implement a new listing page for person detail, showing the detailed profile of a person. We have the example in the backend. In here as well, I guess we can do API/person/1, for example. We see this on the backend. The homework is make this in Vue.js as a new component, as a new URL. And everything that you need to learn is, or all the examples are of course in the repository, but you'll have to make that happen yourself. So, okay, I mapped the state. I reached out into a module, got its data, pulled it up to the component and displayed it here. Does it make sense? This is the same with actions as well. So we had certain actions here, right? Fetching people is an action here, listed on the store, right? This is again the store module, the person module. The action is listed here. All the actions that interact with the backend or do anything should be here. And I need a way to make use of these actions in the components themselves. because I want to fetch the list of people whenever I create this component. Does it make sense? Whenever I refresh the page, I create this component, and that's actually when I want to fetch this information and keep it in the store. If you look at it, I do it by something called map actions. It goes the same. It's the same as mapping state. The syntax is a little bit different. It's a little bit easier because actually actions are global in the whole state. The data is per module, but you can directly type the name of the action and it will be available to you as a method. Now you see, this is the definition of our component. All right, this object is the definition of our component in our script. We're exporting it, and we have a created function, which is called when that component is created for the first time. The name is obvious, right? It says created. So whenever this component is created, this function is called. And what I want to do there is I want to call this.fetchPeople. So start this process, fetch the list of the people, and because I'm going to display that. All right? And where does this method come from? It comes from mapping the action. I'm mapping an action in the store as my component method so that I can call it. So I map the state, take the data that I'm interested in from the store, but I also map the actions so that I can use them in my components. Again, there are other ways of doing this, but this is kind of the most straightforward way of doing this. Mapping the action so that you can basically do this.fetchPeople. It's as simple as calling a method this.fetchPeople. Normally, you could have other methods here. I don't know. Like, let's say log something would be a method. It would take a parameter, something, and I would do console.log something, for example. And I can then do this.log something. And if I go to, I have a typo here. If I go to the application, it's already there. Hello class, are you with me? The log is there. So I can add whatever method I want to this methods list in the component, and I can call them in other functions, basically, when I create something. So this is the way to build components in Vue.js. You have the state, you map it. You have actions, you map it. The individual syntax is a little bit convoluted. It's very confusing if you look at it. You know, there are 3 dots and then map state, and then that's like a function call which takes an object, whereas this is 3 dots function call which takes an array of strings. These things you will have to learn or just copy and paste. We usually do copy and paste these kind of stuff from one component to the other because that makes the most sense. But this is mostly how we do stuff. And one more thing that I want to show you is the router.
Why start with an empty state and then call fetch, as opposed to if you look at your person.js file, where you start off with the current initial state as an empty list, why not make the API call to fetch the latest list of people from the server in the initial state?
In the initial state, because you cannot do that. One way you could do is you could embed the JSON in the HTML and then try to parse that, but this has to be asynchronous anyway. because this is a static. This will be a static JavaScript file that will be downloaded to the client and then executed. So it will, like, there's no way that you can do this with a blocking operation. And the thing is, this is a very naive implementation. Most of the time, you don't really know which components will be in which page because they are dynamic based on if the user is logged in, if they have certain preferences. So mostly, you don't really need an initial data when you load a page, and you just defer that decision to the individual components, because some component may display you, I don't know, like a recommendation engine in YouTube displays different recommendations whether you're logged based on if you're logged in or not. So you don't, and maybe you just remove the recommendations altogether. In that case, you wouldn't display anything, and you shouldn't then pull the data in as well. You shouldn't be making an expensive API call. So you defer these decisions to the components themselves most of the time. They decide, hey, I'm coming onto the stage, then I will do this data call and display it. Sometimes they say, yeah, I don't need any data. So it's up to them. There are certain cases where you do initial calls in the state or in the store, but that's kind of a bad practice. It would be better if it was triggered from a component. Because as I told you, the way to build stuff in Vue or any other modern framework is by making use of components.
So then follow up, if you want to check this component, before you fetch on create, what about checking if you're logged in?
Yeah.
Before, would you do that in the component, or would you store somewhere in some global state that is already going to log in?
I would do that in the router. Normally we do that in the router because most of the time, if you are not logged in, you shouldn't be seeing that page in the first place. And we have something called before enter. I'm not sure if that's the correct syntax. Correct me, Anya, if this is how it works. Anya. Is this correct? Like we have a before enter handler here that has a state. I'm not sure. I'm totally making this up. But there is a way to make use of hooks in the routes so that you do a certain action either before you go into that route or after you leave it, or after you entered that route. And from state to to from next. Okay. So to the route that I'm gonna go, the route that I came from, and next I guess is the same next in the as in the middleware that we used to indicate that I'm done and you can move forward with this. If that's not the case, if you want to customize it per component, as we talked about, like the recommendation engine, you'll definitely do it here. Whether when that component is created or whether you just display it or not, because sometimes you hide it and you display it, and when you click on something, you also want to refresh the data, right? Maybe we can implement a simple button here. Let's put a div here. Button click me. It's there already. I cannot click it. Let's make it clickable. This is the way I attach events. So whenever I click this, it will hopefully make a new network request. So let me see if it does that already. Oh, sorry. Yeah. What's going on? What? No. Just goes crazy. I'm not clicking you yet. So what about this? Like this, you mean? But it doesn't still work. Like this doesn't work. Doesn't make the call. That work. Well, let's try to see if we have anything here. So sources, let's go to person.vue. And I can use breakpoints here as well. Put a breakpoint here, or just fetch people. Yeah, didn't work. Okay, I don't know why this doesn't work. Yeah, like this. Yeah, that's like, it should just be the shortcut, but it just doesn't work. Oh, so store person.js. Oh, it works. Do we see it here? Yeah. Yeah, it works. All right. Yeah. So normally, this is the default way of attaching click handlers. But I thought we could remove this and it would work. I think it doesn't work when this is the first item. Let's see. No, it just doesn't work. Okay, then we just use the full version. We-on colon click, and we assign it to fetch people action. Okay, and again, I refresh this. Whenever I click it, you see a new network request that's done. So it just fetches the new list of people. Let's, for example, add a new person here. And let's click this, and you see the updated list, because I now have the updated users here. Yeah, 3 different people. See, this was the previous result, and this is the next result. And all the requests I do afterwards will already fetch me the updated list. But this is how you build, kind of click events, how you listen for click events and call actions as a result of those events, for example. So you just combine these components and bring them together to make an application. And I was talking about the routes. This is the last thing that I'm going to talk about today, is that basically you define the entry, the path, like slash or slash person. You give it a name, like the index component or the index route, or the person component or the person route, and you just pass in the component definition that you have to import from another file. So here we import index and person components. They are here. You don't need to write the extension. It's index.vue, person.vue, these files. We import them and then we pass them onto our router configuration. So what you do for the homework is you'd create a new route here, for example, do path something, and give it a new component, basically, that you developed. All right. Now this is the bare minimum. And one more thing is, of course, chaining components. So components can host other components. You can use one inside the other when you import it and make use of it in your component. This is also left as an exercise. So find the way to put one component inside the other, to compose them, to make composable views. Like here, you can make this into a component, make the individual person line into a component that you can then host inside the person list, this page, and the homework in the person detail, because you kind of display the same data, right? So you can reuse that component there. So I still have faith in your willingness to do the homeworks. I hope you'll do them. We will be there again for the whole week. We have enough time, and next week we have the workshop. No, what is it called? The study group. The study group again. So I encourage you to come to the study groups, and we'll do these things there. We'll help you out. And I hope to see you on Slack about these things, and I hope you like them. What I talked about today. I can, take any questions that you have right now. Otherwise, we can directly start with the homework for the remaining 20 minutes while we're here and going around and helping you out. How does that sound? Everybody's sleeping. Come on. Am I that boring? Yeah, I know. If you have any questions, just approach me and I will try my best to answer them.
How to make a route is like ID.
Oh, it's the same as you do with as the backend. I think. Yes. Like you do this .id, and then you can directly access it from within the components. It doesn't map to the data, I guess, but you take it as a route parameter somehow. Yeah. You don't need to use a backend anymore? Like the person detail on the backend? Like this? You mean? No. No, you don't. Yeah, because I want to show you how to convert them from one to another, but you don't need them. Any other questions? Please.
When you do the map actions, are they available for all the components or is it specific?
They're available to all the components. But every component has to do their own map action themselves. Like every component can map any action. So any component can map any action, but unless you call map actions, you won't have them as this dot something.
So it's available, but if it's not used?
Yeah, it's not there. Any other questions? Nobody asked me if I would like to have a beer. I would definitely like to have a beer. Thank you, and see you hopefully next week.